I'm here with Luke at IndroRobotics. This is the area known as DART. Luke, tell us about DART.
Absolutely. So DART is our drone and advanced robotic testing and training zone. The goal of this site is to take our unmanned systems, both from the ground and from the air, test them, the brand new ones, but also certify the operators to use this equipment effectively. So what we have here is a number of sites, different environment types. We have sand, gravel, water. We have an incline test, slope terrain, rugged terrain, stairs, gates, confined spaces, and gaps. These are all standardized tests that we can use to score and evaluate each of the robots that we want to deploy in the real world.
Okay, Luke, you've got a whole audience in front of you here. I'm not sure if the camera can pan over. They're waiting for you to give them a demonstration. So what I'm going to do is I'm going to give you our mic. So now you're double mic'd here. Okay, I'm going to get out of the way. And why don't you just go through this whole demonstration, let our viewers see what you're doing here. This is a robotics playground. I'm going to let you play.
Awesome. Thank you so much. So yeah, obviously we have a number of robotics platforms here. Our goal with unmanned robots is to take the right robot for each environment. So whether it's tracks, whether it's wheels, whether it's legs, and then outfit that robot with the compute, the connectivity, the cameras, the sensors, whatever is required for the application. The application can take a few forms. It could be something like delivery, or it could be something more commonly like inspection in fields like mining, solar, oil and gas, utilities, just to name a few. So most of our robots end up looking something like this large guy over here. So we call this one SSR. So this is our Street Smart robot. The goal of this robot is to evaluate the condition of sidewalks here in Ottawa, or bike lanes. So the robot base is the Bunker Pro. So it's a large tracked platform. It comes equipped with 2D safety lidars, so we're not hitting, people or pedestrians or bikers. The other thing is 2 3D lidars on the side, so it's able to capture 3D data in real time, understand its environment. It also has a thermal, optical, and rangefinder camera with a cute little windshield wiper as well. So we're able to use this robot in all conditions at all times of the year. This is just an example of one application. Not sure if the camera will be able to catch it, but we do have a robot running autonomously here in the back, and that robot we've used for substation inspection. So a lot of our clients tend to take a reactive approach. We want them to take a preventative maintenance approach, where let's gauge the quality and efficiency of these assets over time, and should something happen or they start to deteriorate, we can fix it before it becomes a problem. We don't want any power outages. That's bad. If we can turn our attention over here to the quadrupeds, the quadrupeds are great for anything with multi-level inspection or very rugged terrain. So these are very advanced robotic systems. You can see here that I can actually push and pull this guy, and he's gonna adjust accordingly. This is the sort of robot that I would want in the real world. This one's actually IP68, so it can be submerged underwater. Where something like this is a smaller developmental platform that's meant to reduce the barriers to entry for someone trying to deploy this sort of robot or develop with this sort of robot. It's really made the adoption of this sort of technology more widespread across a wide range of industries, some of which I've already mentioned. On the drone side, you can see we do have a large netted area. We also have some tethered points as well. The idea here is we want to be able to test and certify new drones or existing drones with new payload configurations. The other thing too is we want to be able to take a basic pilots and turn them into advanced pilots. So we want to be able to train people to operate these assets effectively, even in mission critical scenarios like search and rescue or fire relief. That is the DART site and a lot of our solutions here. I'm glad you could tune in and check it out.
Hey, thank you for that, Luke. That's awesome. What's going on back here? This guy back here, way over here.
Yes, so we're doing an autonomy test right now with this robot. This robot was actually deployed into the real world at a substation to gauge the effectiveness of the assets there for 24 hours a day, 7 days a week. We want eyes on for, as I mentioned, preventative maintenance, but also security, and to be able to get eyes on during emergency response scenarios. So should something go wrong in the field, we want to have eyes on so the right resources can be deployed quickly to solve that problem fast. Street Smart Robot, yes. Yes. So as mentioned, this one's going to go up and down bike lanes here in Ottawa, hopefully soon, with the idea of looking for things like potholes and cracks, extend the amount of time that people can bike here in Ottawa, because we all love biking.
We do.
Yes.
We do. Luke, once again, thank you so much. We really appreciate your time. Thank you.